Welcome to our deep dive into something fundamental but maybe overlooked, structured cabling systems, or SCS.
That's right.
We've got Chapter 2 of the ITSM manual and some slides here, and, well, our mission is to unpack what SCS actually is.
And look at its core parts, how it's managed.
Exactly, and why this wiring is, so crucial for basically everything digital we do. Hopefully you'll have a few aha moments about those connections.
Definitely. Think of SCS as the standard way to design and install the physical network layer in buildings or across a campus.
So it's not just random wires.
No, far from it. It's a specific architecture for ICT connectivity, a planned system.
Okay, an organized system. So what are the main pieces of this system?
Well, you can think of it hierarchically. You've got the backbone cabling connecting the main hubs.
Right.
Then horizontal cabling that goes out from those hubs to where the users actually are the work areas.
Got it.
All these connections are housed and managed in specific telecommunication spaces, your TRs, ERs, TEs, EFs, the closets and rooms.
PR, telecom room, ER, equipment room.
Okay. And critically, there's administration keeping track of it all, plus the physical pathways that hold the cables.
Let's start with the backbone then. That sounds like the main artery.
It really is. It links those key telecommunications spaces. It can be inter-building, just inside one building,
Okay.
or inter-building connecting multiple buildings, like on a campus.
And what kind of cables are we talking about here?
Usually copper twisted pair or fiber optics. The choice depends on, distance and what kind of data speeds you need, the application class.
Right.
And essentially, physical things matter, like temperature. For copper, higher temps actually shorten the maximum usable length.
No kidding. Why is that?
Heat increases electrical resistance, degrades the signal faster over distance.
Wow. Okay. So backbone connects the main rooms. Horizontal must be the part that reaches my desk.
Exactly. Horizontal cabling runs from that telecom room or enclosure out to the work area outlets, like the jack in your wall.
And there are rules for that length too, right?
Oh, yes. Very strict. Maximum 90 meters, that's about 295 feet, for the cable itself. Ensures signal quality.
90 meters. Okay.
And standards usually call for at least 2 outlets per work area for flexibility data, voice, maybe a spare.
Makes sense.
You also sometimes see something called MPTL, modular plug terminated links. It's like a direct connection, skipping the outlet sometimes.
MPTL. Okay. And then the final step, in the work area itself. The cord from the wall to my device.
Right. The equipment cord or patch cord, that usually has a max length too, typically 5 meters or about 16.5 feet. Keeps things tidy but flexible right at the desk.
Okay, so we have backbone cables connecting spaces, horizontal cables reaching users. How do they all link up inside those telecom rooms?
That happens using cross connections or interconnections, usually in the TR.
Cross-connect versus interconnect. What's the difference?
So cross connections use patch cords between 2 patch panels, one representing the horizontal cables, the other maybe the backbone or switches. Interconnects connect a patch panel directly to active equipment. Cross connections are generally preferred because they're much more flexible. Easier to make changes later using just patch cords.
Flexibility. That sounds like it leads right into administration. Why is managing all this so vital?
Oh, it's absolutely critical. Without good administration, you've got, chaos, a tangled mess.
Right.
Proper administration makes moves, adds, changes. MAC works simple. And troubleshooting. Forget about finding a fault quickly without it. Imagine tracing one unlabeled wire in a bundle of hundreds.
Yeah, impossible. So what does good administration involve?
3 key things.
Yeah.
Unique identifiers for every cable, path, space, outlet. Everything. Accurate records, maps, databases, spreadsheets, linking those identifiers.
Like a catalog.
Exactly. And clear labeling on the actual components. Labels, tags, maybe even RFID nowadays. You need to be able to see the identifier in the field.
Identifiers, records, labels. Makes sense.
And color coding helps too, especially at patch panels, like using orange for the demarcation point for the service provider, green for network connections, blue for horizontal cables. It's a quick visual check.
Oh, that's handy. So the colors mean something specific.
Often, yes, according to standards
Yeah.
like 606. And the level of detail in administration scales up,
Yeah.
Simple for one room, much more complex for a whole campus. They define different classes of administration.
Got it. Okay, briefly then, how are these networks typically laid out?
That's it.
Topology.
Topology is just the physical or logical arrangement.
Yeah.
You might hear about old ones like bus or ring.
Yeah.
But for modern SCS, the standard is overwhelmingly the star topology, or often a hierarchical star.
Star. Why is that preferred?
Reliability and management mostly. In a star, each connection goes back to a central point, like the TR. If one cable fails, it usually only affects that one connection.
Unlike a bus or ring where one break can take down a whole section.
Exactly. Much easier to isolate faults in a star.
Okay. And finally, all these cables need to be routed and protected, right? That's when pathways come in.
Yes, pathways are crucial. They support and protect the cables, things like conduit, metal, or plastic pipes. Cable runways or trays, often overhead. Surface raceways that mount on walls. Open-top supports, like J-hooks.
So different ways to keep cables neat and safe.
Pretty much. And there are rules for those, too, like how full you can tack a conduit, the fill ratio. Too many cables causes heat, potentially damages them, or makes future pulls impossible.
Makes sense. We've covered a lot. The backbone, the horizontal runs, the work area, how connections are made, the vital role of administration, the star layout, and the pathways.
It really paints a picture of how this structured physical layer is the essential foundation, even with all the talk about wireless.
Yeah.
The performance and reliability often come back to this well-organized, wired infrastructure.
It's quite the system.
Yeah.
So thinking about this structured, standardized approach, what does this detailed organization for something as fundamental as cabling suggest about how we build resilience and efficiency into, well, any complex system?